All right, like I said a second ago, this is the last section of this chapter. And look at it. It's called coordinate geometry. What is that coordinate thing? Like, what's the first thing that pops in your mind when you think of coordinates? Coordinate plane. What else? Give me some just words that just pop in your head. What is it? X and Y. All right, X and Y what? What are those lines? X and Y axis, right? Give me a couple other words. Some things that we had to find in the coordinate geometry. There were three main things where they give you a couple points and you had to find some stuff. The slope, okay. Well, you had to find the slope. You had to find the equation of a line, right? We did that. Did we do that? Did we find an equation of a line given 2 points? I don't know if we've done that yet, did we? Okay. And then what else? So we found the slope, found the equation of a line, a couple other things. The distance, right. We found the distance. And there was one more thing we found. I don't think I guess we are going to do a little bit of that today. So we're going to do the midpoint, right. So distance, midpoint, slope. Everybody got that? We're basically just going to do that again, but we're going to kind of do it all together. All right, does that make any sense? It may not. Let's start off right with an example. And I tell you what, let's see if I got enough. Let's grab this just to make it kind of a little more accurate instead of just, oops. Oh, let's try this again. There we go. All right. How many does this go over? 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. I got plenty of room. All right, I'm going to plot 3 points, and I'm going to make a triangle out of those 3 points, okay? So here are the 3 points. So you could do this as well. The first one, I'll tell you what, I'll write them down. So point A is negative 7, 1. Point B is 1, negative 5. 1, negative 5. And point C is 7, 3. We're going to plot those 3 points, and it's going to make a triangle, right? 3 points forms a triangle. Would you agree? Yeah? All right, so let's plot them. Negative 7, 1. So 1, 2, 3, 4, 5, 6, 7. Positive 1 right there. So that right there is point A. Let's do point B. It's 1, negative 5. So I go 1 on the X, negative 5 on the Y. 1, 2, 3, 4, 5 right there. That's point B. And then point C is 7, 3. So 7 is here, and 3, 1, 2, 3 right there. And that's point C. So if I connect those points, what do I get? I've said it twice already. Triangle, right? So there's one side of the triangle. There's another side of the triangle. And here's the third side of the triangle. Everybody good? All right, that's pretty easy. So what does the question say? Well, it says, I'll put it over here. It says find the slope and the length of each side of the triangle. So find the slope and the length of each side. Of the triangle. I'll just put that in there. Of the triangle. Okay? So really, this should not be brand new to you. All right? The only thing that's new, because what do they call it? They don't just call it coordinate geometry. They call it coordinate geometry of what? Triangles. Okay, so we're going to use that coordinate geometry, but we're going to deal with triangles this time. We didn't really do that. We just did straight lines before, didn't we? We just found the length of a line segment. We found the slope of a line. But now we have a triangle. But look, all three of these sides are line segments, right? So we could find the slope of a line segment, and we can find the distance or the length of a line segment. So let's do that. And you don't really even need the picture of the triangle, do you? Do you? No, because what are our 3 sides? Let's find, what are our 3 sides? You can just look at this without even looking at this picture, but if you want to glance over to it for a little hint, you can. So just looking at these 3 points, what would the 3 sides of my triangle be? Well, you'd have side what? AB, right? What else do you have? AC. And then what else? BC. So do you even need the picture of the triangle? You really don't, because you've got all three of these points. I got to find two things. Now, it's a little bit of work, right? But if you understand how to find the slope in the distance formula, then it shouldn't be that difficult. So I'll tell you what, I'm going to drag this. Whoops. Let's see if I can get rid of that. Oops, it's not what I wanted. What did I do? Oh, I know what I did. Clicked on that. Let's try this one more time. And it's going to grab it again. Oh, sorry. See, this thing's getting in my way. Let's try this again. Grab that. Now I'm going to push that. There we go. That's what I wanted to do. And here, let's do this. Let's start with a clean slate here. All right, there's my points. Let's push it over here. And let's find the stuff. So I'm going to make two columns. The first one is for the slope, and the next one is the length, or the, what do they ask for? Yeah, the length of each side. I'm going to just call it distance. Is that all right? All right, so I'm going to find the slope of three things. I want to find the slope of what? AB. So let's find the slope of AB. So how do I find the slope of AB? It's rise over run, isn't it? Or the change in what? Y over the change in X. What does that mean, the change in? What do we do with those two things? I subtract, that's right. So I subtract the Y. So here's AB, these 2 points right here. -7, 1, 1, -5. Everybody with me? All right, so let's subtract the Y's. Doesn't matter what order you subtract them in, as long as you subtract the other one in the same order, okay? So you want to do it like this, just 1 minus, is it 1 minus 5? It's 1 minus -5, which is 1 plus 5, all right? Let's just write it down, 1 minus -5, just so you know where we're getting these numbers from, all right? I don't want to do too much in my head. And now we do the x's in the same order. Let's go to the top one minus the bottom one. So it's -7 minus 1. So it's -7 minus 1. Let's see what that is. This is 1 plus 5, which is 6 over, what's that? Let's add the opposite. That's -8. And if we reduce that, right, 2 goes into that 3 times, 2 goes into that 4 times. There's a negative, so it's -3/4. Everybody with me? Tell you what, I'm going to do the distance down below here instead of making 2 columns. Just don't have enough room. All right, so let's do AC. Let's do AC, the slope of line segment AC. So again, put a little fraction thing here, change in Y over change in X. AC, so it's that first one and the third one. Let's do the Y's first. That goes on top. So it's 1 minus 3. Let's do the X's, -7 minus 7. And what's that? That's -2 over, what's that? -14. Is that right? And that's what? 1, 7. Good? All right, let's do, what's the next one? BC. Let's do the slope of BC. Once you do these a while, then it starts coming back to you, doesn't it? How to find the slope. And you should be able to do it really quick. BC, it's these bottom two right here. So it's -5 minus 3. This is good practice for finding the slope. And then it's 1 minus 7. And that's -8. That's -6. Reduce, what's that, 4/3? There you go. So tell me something. I don't think they ask you, but I see it. Tell me something about a couple of these slopes and tell me something about an angle of this triangle. Compare the slopes. This is -3/4. That's 1/7. Do they have anything in common, -3/4 and 1/7? No. What about this 1/7 and this 4/3? Do they have anything in common? Okay, what about this one? The -3/4 and the +4/3. Do they have anything in common? They kind of do. What are they? They're what of each other? They're negative reciprocals of each other. Exactly right. Which means, what's true about AB and BC then? They're perpendicular. That's right. So I could say that AB is perpendicular to BC. So if you come up here, AB, there's AB right there, there's BC right there, they're perpendicular to each other. So what does that mean about this angle right here? It's a right angle, okay? And we know definitively, we We're not just looking at it and say, yeah, it kind of looks like a right angle. That's not good in geometry. Okay, you can't say, yeah, it kind of looks like it. No, you want to be definitive, which means absolutely true about it, or absolutely certain about it. Okay, so AB has what's that? Negative 3/4, and then BC is positive 4/3. They're negative reciprocals of each other. They're perpendicular, which means it's a right angle. So it is a right triangle. So you can say for sure, without any shadow of a doubt, that that's a right triangle. Everybody good with that? All right. Let's. We might be able to guess. We might be able to look at this triangle and guess a couple other things. What might you guess about like the lengths of the sides? Because we're going to do distance next, right? Just a wild guess. What do you think might be true? We don't know for sure, but what might be true? Does it look equilateral? It doesn't really look equilateral, but it does look like maybe AB and what? BC could possibly be equal to each other, okay? All right? So anyway, it's just something that we're looking at. We're like, okay, that might be true. Let's see if it actually is. So how could I find out if they're actually true or not? Find the distance, that's right, okay? And use the what? Distance formula, good. Okay, so here's my points again. I'm going to push these over here up in the corner, right there. All right, so now we're not finding the slope. What are we finding? The distance. Okay, so let's find the distance between all these points. Again, what are our points? Let's do the first one, AB. All right, so let's find the distance or the length of line segment AB. Well, we got a distance formula, don't we? So what is the distance formula? Do you remember this one off the top of your head? Big old square root. Yeah, subtract the x's and square them, and then plus subtract the what? The y's and square them. And it really doesn't matter what order you do them in. And it doesn't matter if you go x1 minus x2 or x2 minus x1. Because, right, the only thing difference between going x1 minus x2 and x2 minus x1 is that you're going to have one positive, one negative. But squaring it's always going to make it what? Positive. And when you add them, right, adding this one plus this one, does it make any difference? No, it doesn't matter. All right, so anyway, let's do the x's. That's how we learn the formula, so let's do the x's. So subtract the x's on AB. So what do we got? Negative 7 minus what? 1, okay? And let's do the y's over here. So it's 1 minus negative 5. It's kind of the same math as we did for the slope, right? Because we subtracted the y's and we subtracted the x's, yeah? But we're doing a little bit more to it. So what's this? Negative 8. And then we're going to square it. I'm going to show you every little step. You might be able to do this in your head. You add those up, and that's what? 6. And that's squared. Let's do it over here. What's that? 64, right? Negative 8 squared, because negative times negative is positive, right? And then 6 squared is 36. What's that? 64 and 36. Well, that's 100. Do I just leave it square root of 100? No, you can simplify that, and you should be able to do that in your head. You shouldn't need a calculator for that. What's the square root of 100? It's 10. That's right. It's just plain old 10. It's not the square root of 10. All right? It's just a whole number 10. Because what number times itself is 100? Well, 10 is, right? It's not the square root of 10. Everybody see that? That's a big mistake. I just graded a test last period of one of the other classes, and somebody did this. Equals the square root of 5, and then they, whoops, let's try to make it a circle, and they circled it. Is that right? Should I give them credit for that? You're like, yeah, sure. It might be me sometimes, so sure, give them credit for it. But if they circled that, I should mark that wrong. Would you agree? Because that's not correct. The square root of 5 is not the same thing as the square root of 25. What's the square root of 25? It's the whole number 5. What's the square root of 5? Like approximately. 2 point something, right? We're not sure if it's 2.5. It's not necessarily half, okay? The square root doesn't mean half of it. But what number times itself is 5? Well, 2 point something, right? Because 2 times itself is 4, correct? It's a little bit more than that. Okay, 2 point whatever it is. I don't know, 2.1, 2.2, probably something like that. So 2.1 or 2.2 is not the same thing as 5. So that would be wrong. Well, you'd be glad to know that I did this. I circled this, and I said that's equal to 5, and I actually gave them credit for it. Wasn't that nice of me? See, I'm not all mean. I give a little grace sometimes. But really, for an honors class, I would mark it wrong. Sorry, guys. But that's the way it is. All right, so if you wrote the square root of 10, I would mark it wrong. All right, it's 10. Everybody good? All right, enough talking. Let's do some more. Let's do BC this time. I think I did AC before. Let's do BC. There's a reason why. All right, so the distance equals big old square root, and I like to put the shell of the formula or the equation. I guess you can call it a formula. All right, so let's do the same thing. So BC, we're doing these two right here. So it doesn't matter if it's the x or the y, but we usually do the x first. So it's 1 minus 7, or 7 minus 1. It doesn't make any difference. Let's just go 7 minus 1. That way we won't get a negative. It won't bother us. What about this one? We could go negative 5 minus 3, or we could go 3 minus negative 5. Doesn't make any difference. All right. Oops, what in the world is that? Equals. All right, so this is what? 6 squared. This is 8 squared. That looks familiar, doesn't it? What's that? 36 plus 64. That's the square root of 100. What's the square root of 100? It's 10. So what did we just find? We found the length of AB and BC. Remember we talked about that earlier? AB is 10, right? And BC is what? It's 10. So sure enough, they are equal to each other, and we know exactly how much they are as well. We could find AC just by doing Pythagorean theorem if we wanted to now, couldn't we? I could go 10 squared plus 10 squared equals, we'll call it D for distance squared. All right, I could do it that way, but let's just do some more practice with the distance formula. Let's keep it down here so we can see. And then what's the last side? AC, correct? So let's find the length of AC. Let's do this a little faster. So AC, let's do this. Squared. No, we just did BC. Right? We did BC. So we did AB, we did BC, now we're doing AC. So it's that one and that bottom one right there. So it doesn't matter what order. I'm just going to go the first one minus the second one, and then 1 minus 3.
So square root for that one is 10 again?
Right here, it's the square root of 100, right? Why would it change? Square root of 100 is always 10, right? This one may not be the same, though. So what's this? Negative 7 minus 7, that's negative 14, right? And that's okay. I'll just put it there. Squared plus another thing squared, and then what's this? 1 minus 3, that's negative 2. That's squared. What's 14 squared? I don't know. Well, I do. I wrote it down. It's 196. All right, plus 2 squared. We know what that is. And it doesn't matter if it's a negative or a positive, because I'm squaring it anyway, right? If I square a negative, it comes out positive anyway, so it's plus 4. So what's that give me? That gives me the square root of 200. Did you happen to do this in your head when I was talking about it? Did you do this in your head when I was... Remember Pythagorean theorem, right? A squared plus B squared equals C squared. So let's do this in our head. Watch. So 10 squared, what's 10 squared? 100. Plus 10 squared is 100. So D squared equals what? 200, right, because 100 plus 100. How do I get rid of that squared? Square root. So that's the square root of 200, okay? So I could have done it that way, right? Now, but check this out. This is kind of cool. We got square root of 200 down here, don't we? Now, at this point, probably shouldn't allow you to keep it like that because you're honors, but you could keep it like that and I'd give you credit for it. But there's a better way to write it, okay? And it's not using a calculator and getting some calculator number, all right? It would be doing this. Now, I didn't teach you guys Algebra 1. This should have been taught in Algebra 1, but I have a feeling it may not have been. So what I'm going to do is I'm going to, like what times what is 200? There's a bunch of things, but what's the one number times another number? And if I take the square root of one of those numbers, it's going to come out to a nice whole number. 20 and 10? Can I take the square root of 20 and it comes out to a nice whole number? Can I take the square root of 10 and it comes out to a nice whole number? No. Now 20 times 10 is 200. That's true. Okay, but it's not the one I'm going to pick. Okay, there's a really good one that I'm going to pick. What are two numbers that multiply to be 200? It's the... Yeah, I'm not going to go 4 because that's what? 50 times 4, right? Can you take the square root of 50? No. Can you take the square root of 4? Yeah, you can. But 50, you're going to have to break that down even further. So you're going to have to do 2 steps if you're going to use those numbers. It's got 2 zeros in it. What is it? 100 times 2. Exactly right. So watch. I'm going to use... Now, you could have used any of those other ones, but this is the easiest one to use. It's 100 times 2. All right? Why did I pick that? Because, did you learn this in algebra? How to simplify these square roots? Maybe? Apparently you didn't, if you say maybe. Okay. So no would be the answer. That's fine. That's an okay answer. I wish you would have learned this in Algebra 1. It seems like it's something that they should teach you in Algebra 1, but it's definitely an Algebra 2 principle. All right? So at least when your Algebra 2 teacher, whoever it is, next year says, did you learn how to simplify these square roots? Oh, yeah, we did that in geometry. And the teacher's going to say, that's awesome. You had a great geometry teacher. All right, so anyway, what can we do with this? We can break this down into the square root of 100 times the square root of 2. I've done this for you before, haven't I? Yeah, I remember doing this. What's the square root of 100? It's just 10. What's the square root of 2? Can I simplify that? No, it doesn't break down any further than that. So what do I keep it? Yeah, 10 times the square root of 2. That is the answer that in your math classes that they want you to write, okay? They don't want you to write this. They want you to take the square root of 200 and simplify it to this. All right? It's 10 square root of 2. And some people look at that and say, well, it doesn't look any more simplified. That looks a lot more simple than what that looks like. Okay? And it's true. It kind of does. But if you can take the square root of something in there, you need to do it. All right? That's basically what they want you to do. If you can take the square root of something and it come out to a nice whole number, you could do it. Somebody said, watch this. Zach, you said 20 times 10, correct? Now, can you take the square root of 20? No, but you can break down 20 into something that you can take the square root of. What times what is 20? And you can take the square root of one of those numbers. I'm not going to use 2 times 10 because I can't take the square root of 10. I can't take the square root of 2. Right, 5 times 4, 4 times 5, right? So 4 times 5. Do you agree? What about 10? That's just 2 times 5, isn't it? So watch, I'm just going to write 2 times 5. Everybody with me so far? All right, not too bad. Now what I'm going to do is I'm going to break it down into their individual. Well, I see something. Do you see something? What's that 5 times 5 going to give you? It's going to give you a 25, isn't it? So let's write it like this. Let's write it 4 times what? 25 times what? 2. Everybody with me? This isn't so hard. A lot of people really freak out over this stuff. All right? It's not that bad if you just break it down into numbers that you can take the square root of. And you got to know your square roots. I mean, you got to know things. Some of these things got to pop in your head. So 4, can you take the square root of 4? Yeah, you should know that off the top of your head. What about 25? Absolutely. 25 is one of those numbers I can take the square root of and get a whole number out of it, right? Okay, so here's what I'm going to do. I'm going to break it down into the square root of 4, and then what? The square root of 25, and then what else is left? The square root of 2. See how I can do that? There's a rule in algebra. We didn't really go over it, but there's a rule in algebra that says if you got all these things that are multiplied underneath that square root, you can break them down into their own square roots. See what I did? See, that 4's got its own square root. That 25's got its own square root. And that 2 has its own square root. But the reason I picked 4 and 25 is because I can take the square root of 4. What's the square root of 4? Plain old 2. Times, what's the square root of 25? That's a 5. And the square root of 2, I can't do anything with that. Now I can multiply here. 2 times 5 is 10 times what? The square root of 2. Would you agree it was way easier coming up with 100 times 2, right, to get that than going through all this mess? Yeah. It still works, right? But it was way easier doing it like that. All right. You got a free algebra lesson today. I won't even charge you for it. Is that right? Okay.
Yeah.
Let's give you another definition. This seems to come out of nowhere, but it really doesn't. Oh, come on. Let's try this again. There we go. This is pretty interesting, actually. What I'm going to do is I'm going to find the midpoint. I'm just going to draw it, okay? So I'm not going to do the math with it just yet. Eventually you will. But right now I'm just going to show you what's true. So if I'm going to grab that thing right there, there's the dot right there, which means, where do you think that dot is on that line segment? It's at the midpoint, exactly right. So let's see. Let's try it one more time. Got to remember where it is. It's right there. And put a dot right there. So that's the midpoint of that side. Everybody with me? Remember, we already found the slope and the distance, right? What was that third thing we had to find back earlier in the chapter? The midpoint, right? So now we're going to find the midpoint. So here's the midpoint of that side right there. Everybody with me? I just found the midpoint of those two sides. Now what I'm going to do is I'm going to connect those two midpoints. Let's do it. Come on. There we go. I'm going to connect those two midpoints. Boom. Right there. Now, there's something, and what we can do, we can say this is a midpoint, so this side is equal to this side, and then this one is equal to this one. That means those two are the midpoints. Agreed? Now, just by looking at it, we don't normally do this, and there is a proof for this, and I've got it written down. I don't think I'm going to go through the proof with you on this, but there is a proof for it. If you're really, really interested, you can come see me, and I can show you the proof, okay? It's probably in the book, but I'm not going to go through the proof with you. I just want to tell you what this does. Now, it connects the midpoints. By the way, when you have a segment that connects the two midpoints of a triangle, we give that a name, and we call it the mid-segment. Okay? So that pink one right there, see that? The pink and the pink? Okay, that's the mid-segment. Why is it the mid-segment? Because it connects what? Two midpoints of a triangle. Exactly right. Everybody see it? All right. Now, there's two things that are, besides connecting the midpoints, this mid-segment right here, there's two things that we know about that mid-segment, and this is pretty interesting. So the first thing that we know about the mid-segment is that it's parallel to that third side. Does it look parallel? Yeah. Can we always go by it looks like it? No, we can't, okay? But it does look like it, though, doesn't it? All right? So we can be, fairly confident that they're parallel to each other. Again, there is a proof for it. We could show you the proof, but just believe me that this and this are parallel to each other. We good? All right. So the mid-segment, it's parallel to the third side. To the third side. The third side, what does that mean? It means the two sides that we didn't connect. All right? That makes sense, doesn't it? Now, there's something else about it. That looks pretty much like it would be true just by looking at it, right? Again, it's not always a good way of going about it, but there's something else about that mid-segment to that third side. And this is something you may not have thought about. But watch this. I'm going to copy this. I'm going to copy it, and I'm going to paste it. All right? So I didn't change the length of it. Agreed? If I can grab it. Come on. Nope. Come on. Why is it so difficult? There we go. All right, now what I'm going to do is I'm going to put it right here. Let's drop it down a little bit. Tell you what, let's make it a little thicker. There we go, so you can see it a little bit better. And let's change the color of it. Let's make it like a yellowish color. Okay, you see that? I put it right there. Now, what if I'm going to paste it again. Okay, there, see if I can grab it this time first. First shot. Look at this. Now, check this out. I'm going to put this right there. What's true about those two things? What do you think the relationship between this mid-segment and that whole entire third? It's 1/2 of it. Exactly right. So the mid-segment is what? 1/2 the length of the what? Of that third side. So those are two things that are true about the mid-segment. I think that's pretty interesting. And if you're like, well, how do you know that's the mid? I mean, we kind of showed it right here. I think I went a little bit. Did I grab it? There we go. Just scooch it over just a little bit. There we go. It matches up pretty good, doesn't it? So with this computer program, it's kind of nice. I copied and pasted it, and it definitely looks like two of these, right, equals that third side, or two of these right here, these mid segments equal that third side. Would you agree? Yeah. All right. It's not really a proof, but I got a proof. It's right on my paper. If you want to see it, you can see it. All right. Just believe me on this one, though. All right. So it is a theorem. It's called the mid-segment. Well, it's actually, it's the mid-segment theorem. Okay. Which is kind of interesting. We good with that? Now, what they're going to do, and I think I'm going to continue this tomorrow. I didn't think I'd finish this whole lesson today anyway. But I'm going to finish this tomorrow, and what we're going to do is we're going to give you a situation where I give you a triangle. Here, I'll tell you what. Let's go let's scooch this up to here. Now we'll just stay right here. Here's the situation. Watch. If I connected, let's say the midpoint of this one right here and the midpoint of this one, and I connected them, okay? What we're going to do is we're going to find the actual length of the mid-segment, all right? Because we're going to have a point. You got to find the midpoint, so we know how to find the midpoint, correct? We know how to find the midpoint of this, so I'll know what that actual point is, and then I'm going to connect from here to here. Then I'm going to find the distance of that mid-segment, right? If I connect the midpoints, that's the mid-segment. And I'm going to take the distance of that mid-segment and show that it's half the distance of the third side. So I'm also going to take the distance of the third side. So whatever my length of my mid-segment is, I'm going to show that it's exactly half of the distance of that third side. All right? It's not really a proof. It's just showing that it's true. All right? Technically, that's not a proof, but it's just demonstrating that that is true. And we're also going to show that that mid-segment is parallel to this. How do I show that two line segments or two lines are parallel to each other? Find their what? Find their slopes, okay? What's true about their slopes if they're parallel? They're going to be the same slope, going to be equal to each other, okay? Everybody with me on that? That's what we're going to do tomorrow, all right? So we're going to find the midpoint, not of this one right here. We're going to do a different one. But we're going to find the midpoint. We're going to find the midpoint. We're going to connect them, right? And that's the mid-segment. And then we're going to show that the length of the mid-segment is half of the length of the third side. So we're going to have to find the distance of both of those. Then we're also going to have to find the slope of both of those. So find the slope of this one, find the slope of the mid-segment. We're going to see that they're equal to each other. And if they're equal to each other, that means they're parallel. And that means my theorem is basically correct. Okay? Bet you can't wait, can you? All right, so that's what we're going to do tomorrow. All right? And then I believe, we'll do that big example, and then we'll do a third example as well. And we're going to find three mid-segments. All right? So we're going to find the midpoint of this one, and this one. We're going to connect them, and then we're going to learn some stuff about that. Okay, enough of that. That's it. 1 to 16 was the homework. You probably will not be able to do the majority of these, but check the first few. I don't have it in front of me, all right? But if you want to get started on it, if you think you can get started on it, go ahead and do that, but I'll officially assign it tomorrow, okay? Everybody with me? Yeah? All right. Simone, you wait?
Yeah.
All right.